So welcome everyone, my name is Marina. I work at F6S alongside my colleague Luisa that is here today also. Today we will be having this webinar focused on our second and last open call for innovators of this project AIPlan4EU. And today's webinar will be more focused on tracks B and C. You will understand everything about what I'm saying a bit further when people start to explain what this means. During this webinar, please feel free to ask your questions. Just write them in the chat. We will be addressing them as we see them. So feel free to clarify all your doubts so that you can apply to our open call. Okay, so on today's agenda, we will start by hearing from Andrea Micheli. He will give us an overview of this open call and the project itself for the ones that are not yet familiarized with it. Then we will hear from Sebastian Stock that will focus a bit on what is this of tracks B and C. He will present them and also the TSPs. And then we will hear from two of our use case owners, Elisenda from Navozyme and Grigore from Applied Research Solutions. They will explain you what their use case is about and what they are looking as a partner to solve the use case. And finally, we will hear from my colleague Luisa. She will walk you through the open call and what you need to do to apply, the procedures, what you need to fill, where you need to go. She will show you everything about this so you can apply to the open call in time and with no big issues. And by the end, if there is still any questions, you are free to post them in the chat and we will be for sure answering them. But all through the webinar, please write your questions in the chat. We will be addressing them. Just something, okay, just a reminder before I hand the floor to Andrea that our open call closes next week. The deadline is 31st of January. So you can go here to the F6S platform and you can apply. Don't leave it to the last minute because sometimes the system gets overloaded and problems can appear. So go with time. If you have problems, address them to us. We are here to help and to clarify all your doubts. Okay, so now I will stop sharing and I will give the floor to Andrea.
Thank you very much, Marina. So let me share my screen.
Andrea, you're mute. Oh, you're not.
Yes, I learned how to do it
last time.
Yeah. Thank you very much. So I hope you can see the screen and hear me. So I'm Andrea Micheli. I work at Fondazione Bruno Kessler in Trento, Italy, and I am the coordinator of this European project called AIPlan4EU that is funding these open calls. So I will in this presentation I will give you 3 pieces of information mainly. A little bit about how the project came about and what is the scope, what are the objectives from an high-level point of view. Then I will enter a little bit more into the technicalities, so to explain a little bit the vision of what we are constructing and where, let's say, the contributions from these open calls are expected. And then finally, I will give you a brief introduction on how the different tracks of the open calls are structured, so you can probably figure it out a little bit better what Marina meant by track A, B, and C. And then I will give the floor to Sebastian and to Luisa, who will enter more into the details for the specific track B and C. So, well, this is an overview of the partners. We have 16 partners within the project coming from a lot of countries in Europe. And this is a European Horizon 2020 project funded by the European Commission. Yes.
Sorry, you need to change the slide.
I'm on the second slide where there is partners.
No, we are not seeing that. We are seeing the cover.
That is strange. So if I change, it doesn't change?
No.
Let me try again then.
Maybe you can try to share the whole session, not only one page, Andrea, because sometimes it can be a bug.
Okay, can you hear me?
Yes.
And if
yes, it's changing. Yes, perfect.
Okay, fantastic. Sorry, I don't know what happened. Yes, so I was saying that in these slides you are seeing all the partners involved in the project. As you can see, we have companies and research institutions from different countries in Europe, and essentially we came together for around this idea of AI planning. So before explaining to you what exactly we mean by that, let me give you a little bit of introduction of what the call was about. So what the European Commission asked from this project. So not sure if you know, but there is this initiative at the European level that is called the AI4EU. That is the European platform for the AI on demand. Essentially is a website and a set of services that aims at bringing together AI stakeholders, AI resources, trying to overcome fragmentation in Europe. So the idea is to have a single place in which persons who are willing to use AI in their business, people who are experts in AI, and even hardware producers can get together, essentially have a sort of a networking platform, see what are the different initiatives concerning AI in Europe, and have a central point where to meet. The idea is to somehow accelerate AI-based innovation and to drive the European AI market. So that's more or less the ambition. This is not the only initiative concerning AI in Europe. In this picture that I stole from a colleague, you can see a lot of projects in different areas that are funded by the European Commission. We are here essentially, so following up on the AI4EU project who built this platform. Together with us, there are other 6 projects who on the same call as us, so Stairway Energy, DIH for AI, AI for Copernicus, and Bonsaps, and AIPlan4EU. And our aim is to enrich the platform by bringing something new, something different that is currently not there. And so the way in which we interpreted this call, and we won one of the awards, one of the grants, was to bring automated planning. So what is automated planning in a nutshell? So from a very high level point of view, an automated planning system is some kind of software which takes in input a mathematical description, a system specification. Here, system is a very general word, so it can mean you know, a robot or an entire factory, something that you would like to control, right? And you are able to formalize to some extent mathematically. So you are giving the system specification, then you have a known initial configuration and an objective that you would like to achieve. And the job of a planner is to synthesize a plan or a strategy that is driving your system from the initial configuration to the goal configuration. So some examples can be a robot, right? It's in a certain position, you would like to go to the kitchen and make you a coffee. And so that's your initial configuration, your goal. The robot actions, the robot capabilities, so what the robot can do is your system specification. The job of the planner is to synthesize the sequence of commands that you have to submit to the robot in order to actually make the coffee and bring it to you, right? So that's what planning is about. Some example applications. So for example, in robotics, when you have one or multiple robots, the idea of using planning is to somehow automate the high-level decision of the robots, so to achieve flexible, robust, and cost-effective automation. Another possibility is to plan the activities in a factory. So you have you know, some machines who are at work, plus possibly some human operators. And what you would like to do is to come up with a schedule, for example, for 8 hours or for a shift, in order to maximize the production and minimize the costs, maybe the energy costs. Another example, I think Sebastian will enter into this a little bit more, is to organize the agricultural practices. So you have different machines, you have different actors who are working, for example, for harvesting the crops. And the idea there is to minimize the resources, minimize the environmental impact, and so on. So that's the kind of problems that you can address with planning. And the core part of our proposal is that strong planning resources are currently missing into this AI for Europe platform. And what we aim to do with our project is to reinforce the platform by bringing planning as a first-class citizen. So I will go quick on the innovation goals that we set out. So the idea is that on one side, we would like to build something, and I will explain in a moment exactly what we are building. to facilitate the use of planning technology for people who have some kind of planning related problem, right? So we recognize explicitly the fact that planning per se is not particularly useful if it is not integrated into an ICT infrastructure. So for example, if you want to automate the forklifts into a warehouse, the planner per se is capable of deciding where to send the different forklifts at different times. But in order to make it practical and productive, you need to integrate it with your warehouse management system who takes the order, knows the availability of the products in the shelves. You need to integrate with the executors on the forklifts, being they're human or automated, right? So you need somehow to transmit the decision coming from the planner into the machines, and so on. So somehow create an ICT infrastructure in which planning is just one component. And we would like to facilitate this kind of integration, again, to make it more relevant for different application sectors. So these are, let's say, a summary of objectives 1, 2, and 3. Then we have the integration into the AI4EU platform. As I mentioned before, this is one of our core objectives, and we would like to make it possible for users of the platform to actually try out planning, see different use cases that we collected throughout the project about planning, and create a sort of networking around this AI technology. And then also provide some kind of learning, some kind of educational platform that will facilitate the learning of the concepts of planning and lower the access barrier for using planning. And finally, one of our key objectives is to collect different use cases for planning. We would like to bring it back to the research community, these use cases, and create a list of challenges, sort of to drive the academic research towards applications. So that's the 6 ambitious goals that the project is built around. Now, in order to achieve these goals, we have this, let's say, software vision, so to say, in which we have different components that I will try to unpack very quick for you. So the central component that you see in the middle is called the Unified Planning Framework. It is a software, it's a library actually. The idea is that it's a reusable library that allows you to pose planning problem in a convenient way, so using the Python interface, and it abstracts away the specificity of different planning engines. So the idea is to overcome the fragmentation that is present in the planning community, in which different planning engines are capable of solving different kinds of problem or different formulations of problem. The library abstracts away as much as possible all these details and will allow you to pose a planning problem in a sort of unified way. Then we have a number of planning engines that are integrated with the Unified Planning Framework. The idea is that those are actually the workhorses that are actually solving the problem and getting the description of the problem and generating the solutions. And we have a wide variety of different kinds of planning engines. We have plan generators, so actually, this is a planning problem solving a plan. There is also plan validation, so tell me whether a plan is valid or not, visualization, and so on and so forth. And then in the library, we have this central concept of operation mode. So we tried to standardize the different kinds of interactions that you might have with a planning engine. So one idea is, this is a planning problem, give me a solution. That's it, then I'm done. So this works well, for example, in a logistics scenario, right? Maybe, in the morning, you would like to schedule the logistics for the day. So you have the different times at which the trucks arrives and so on and so forth. So you have one single solution. But if instead you are doing robotics, then it's more like planning. So generate me a plan for doing something. Then if something goes wrong, replan or repair the plan that I was having. So it's a more, let's say, closed loop interaction with the planner. And so we try to abstract these different kinds of interactions into operation modes that the library formalizes and the different planning engines implement, so that the specificities again of the planning engines are abstracted away. Now, I described so far essentially the blue, the azure part of these pictures, and this is, let's say, the technological part. So the domain independent planning technology that we are bringing essentially. The the open calls, in particular the tracks B and C, are more concerned with the orange part. So the part that looks towards the use cases, towards the applications. And in that directions, we have two different things. So on one thing is what we call technology-specific bridges, TSB for short. Sebastian will tell us much more about that one, so I will go quick on that. But the idea is to create a set of reusable software components that interface the unified planning framework into some technology that is relevant in some use case or some application. So for example, if you are doing robotics, then the robotic operating system ROS is a very common technology. So instead of for every time you want to build a robot and give him planning capabilities, create a new piece of software, the idea is to have a reusable component that you might adapt for new robots, let's say with a relatively low effort, and this actually is already interfaced, so it already provides the interfacing between the blue part, so the planning related world, and instead the ROS specific parts. Similarly, if you want to solve logistics problem, then there are, warehouse management systems that are, these ICT systems that are able to handle the availability in the warehouse, the presence of forklifts, the availability of workers, and so on. And the idea is that if you have a certain WMS and you create the integration once, then it can be replicated to either a different WMS or a different warehouse that uses the same WMS. So that's the idea of reusing this integration software. And this is actually one of the objectives of our open calls. In particular, track C is explicitly looking at creating technology-specific bridges for the use cases that we already identified, and you can find the list on our website. Track B instead asks you to create a consortium of two entities, one providing a technology-specific bridge, the other providing a use case. I will tell you a little bit more about what a use case is in a moment. The idea is that we have different areas or problems in which planning can play an interesting role, can save resources, can automate something, can save money, and so on. And the idea is to collect as many use cases as possible. And so we have different kinds of open call for this one in the past. In this specific call, in track B, you can still propose a new use case for the project. So this is not particularly relevant for track B and C, but just to give you a flavor, so that this unified planning framework is a software. It is available on the internet, permissively open source, so anybody can take it, use it even for commercial purposes. So it's very permissive in that sense. Is under active development. And we have demos, we have documentation. You can find more information in the links on the slides that will be available anyway after at the end of the seminar. More related to the track B then, what is a planning use case? So so probably you already know what a use case is in general, so some kind of problem coming from an application domain. But what is important when you want to find a planning use case is to understand that planning is a decision-making technology. So it's a technology that should automate or simplify the way in which decisions are made into one process or one machine. It is suitable for essentially two things: to automate things and to optimize things, right? So either you want to optimize some resource or you want to automate some of the decisions. And the key questions that you should ask when writing a use case is essentially these three. So what decisions needs to be automated or optimized? So I have a process, I want to automate, I don't know, the decision of what each worker needs to do at each time. So I'm scheduling, essentially, I'm deciding the course of actions of the workers in my factory, or I have a robot and I would like to minimize the consumption of the battery. So how can I achieve the same objective while minimizing the battery? So what needs to be automated and what needs to be optimized. Second question is, what data is available for taking such decisions, right? So in many cases, these decisions are already being taken, possibly manually, and the decisions are typically made by humans based on some information, either in their minds, so by experience, or because some data is available and they have some plots or something that they use to take these decisions. And so we need to identify what is this piece of information, and if in this information there are things that are constant, so that doesn't change from day to day, versus something that is contingent. So in a warehouse, for example, constant characteristics are the shelves, how many bays you have, and so on. Contingent events might be the orders, right, that change from day to day. And then finally, how often are these decisions to be taken? So this also poses constraints on the performance of the system or to the quality of or level of optimization that we can achieve with the system. So that's more or less the kind of questions that you should ask yourself if you want to write a planning use case. And then finally, what is a TSB? I already more or less told you so. So it's a reusable piece of software that uses the unified planning framework. That's why I depicted it here inside of the orange region. And it is interfaced to some ICT infrastructure, some ICT technology that is relevant for the specific use case. So as you can see, this is more general or a little bit more vague. So TSB can be many different things for the same use case. Okay, so more or less I'm at the end. I wanted to tell you two more things, essentially. One is, what does it mean to integrate in this AI4EU platform? Essentially, the platform at the moment is made of two components. One is a website, is a content management system. The other one is a service that allows you to run software, AI software, without installing anything on your machine. So concerning the service level, so what is called the AI4EU experiments, what we are building is a system in which you can run small-scale demos, small-scale experimentation for the visitors of the platform. The aim there is to showcase the potential of AI planning. So if while proposing your thing, either the TSB for track C or the use case plus TSB for track B, you can already think about what could be shown on the platform concerning this use case. That will be fantastic, right? Because what we are looking for is nice demos. They don't need to be super complicated to scale. They can be on artificial data, so we can avoid, NDAs kind of problem. And there we can somehow showcase the potential of planning on one side. That's what is of interest for the project, but also to sort of give you a prime position for showcasing your use case, your company, what you are doing in your business. And the second kind of integration is simpler. So it's essentially enriching the CMS and providing what we are building and what can be reused. So the UPF, the TSBs, we also have training material, planning cookbooks as downloadable resources. So describe the use case, for example, and link to that the software or the techniques that we used in order to create the demonstrators. So that's what we mean by integrating. This is just some examples that we are putting there. So if you go, by the way, on AI4Europe.eu, you can see that there are many assets and many case studies already labeled with the AIPlan4EU tag. So you can have a look. And finally, the structure of the open calls. I will go quick on that one because Luisa will also enter into the details. So essentially, we had two different kinds of open calls in the project. One that we already exhausted, that is the open call for use cases, in which we really broadly look for different proposals, even wild ones, for new use cases. And we organized workshops with the winner in order to understand really if there is a planning problem there and to see where planning can be applied. And then we selected some winners out of these use cases, the one that looked more promising in terms of realizability, in terms of where planning can bring more value. And we organized open calls for innovators that are divided in different tracks. This is, of course, the one that is open right now and will close, as Marina said, on next week. And here we are looking for new planning engines, and this is what track A is about. And instead, track B is about finding technology-specific bridges and the use case together in a partnership between two legal entities. And track C instead is to develop a TSB for one of the use cases that we identified in the open call for use cases. So that's what we're asking you in track C. There is a list of different use cases. 2 of them will present us today. You can find the entire list on the website. And what we're asking in track C is, are you interested in the challenge of actually creating a demonstrator using planning technology for this specific problem? So that's it. I hope it was not too long. And yeah, so type any question on the chat, even while others are speaking, I will try to answer you. Thank you very much.
Thank you very much, Andrea, for this very specific and clear overview of our open call and of our project also. So now I will hand the floor to Sebastian, that will go into more details into track B and C and into the technology specific bridges. Go ahead, Sebastian. You are muted.
Yeah, sorry. Now I found the button to unmute myself. So yeah, here I want to give more details about technology-specific bridges, which Andrea already introduced a bit. So this is this picture again from Andrea, where the technology-specific bridges provide the interfaces between the planning engines on the one side and the use cases on the other side. So a technology-specific bridge from that perspective are all the components and everything that you need to do in order to actually use those planning engines in the use cases. So what does that mean? So they connect of course, the 2 applications. And so there are components that take into account the requirements of the specific applications to use the UPF. And that means they collect sensor data maybe, or other kinds of data. They maintain the data and transform it. One example would be a warehouse management system. Then they generate a planning problem and process the resulting solutions, so the plans. And also they organize or orchestrate the whole process of generating the problem, calling UP for generating a plan, but also executing the plan and monitoring the execution. So this also involves using the plan back in the system. So for example, if you have a robot, then you also need to dispatch the actions on the robot and check if the effects are what you expected them to be. And ideally, most of those components should be reusable, so that they are not too specific just for that one use case, but at least to the technology that is behind that, such that it could be reused by other examples. So here I would just very briefly give you an overview about the use cases that we already have as part of the consortium. So as Andrea mentioned, they can be really different. So we have space domain and underwater domain, where actions of robots or experiments should be scheduled and optimized. Also a manufacturing plant, where the process should be optimized, but also some use cases for robots where the actions of them are planned and coordinated. So, and as those use cases are quite different, we started with creating a generic TSB architecture that aims to contain all the components that are required in all those use cases. So that means those components don't have to be in parts of all use cases, but in general, everything that's required should be mapped in this architecture. And so here on the left, we again have these ICT environments and the data that's already available. And on the right side, there's a UP library which is used for generating plans. And that means that all the green parts in the middle are basically components that are needed in addition to that for using UP. And so these are the parts of the TSBs. So if we start from the left to right, then we will most often start by looking at the static data that we have and also sources of dynamic data. And often we just start with creating a domain encoder, which basically generates a representation of the domain in the planning framework. So in a very simple case, this can be parsing a PDDL file that you already have for your domain, but most often you will start from scratch. And here you can use the UP library, which provides functions in Python, so that you can write your domain description directly by calling Python library functions. This will then, most often this domain will be static for the use case and is then enriched with dynamic data as that's specific for the problems that you currently have. So it contains goals that you want to achieve in this specific problem, the initial current state of your environment or your system, and all the objects, for example, that you have there. So these two are then given as a problem object to the UP library, which generates hopefully a solution if there exists one. That could even generate multiple solutions, and they can also look quite different. So on the one hand, we have just sequential plans as a list of actions, but UP of course also provides functionality for generating temporal plans. Also, there are these operation modes that can, for example, used for plan validation or for repairing a plan or replanning. So in the next step, we are using this plan in the so-called solution management logic. This part is often really depends on the use case. Therefore, it's here drawn in just one block, and it contains multiple parts like a solution decoder that might transform the plan in another format that you already need or can process for executing a plan. It can have an online executor that, for example, steps to the plan and dispatches the actions on the robot or in your system. But there might be other use cases that don't have this online functionality, but where you just want to visualize the plan and process that manually. Closely related to the online execution is this monitoring part, which looks at the plan and checks if it's still valid and if it makes sense to continue with executing it. And then you might also have an orchestrator component that coordinates the whole process. And these components then mainly talk back to your system or to your robot, for example. So now I would like to give two short examples how these TSB could look like in specific use cases. So one use case that we have is this agricultural domain use case that deals with silage maize harvesting. So in that case, you have to coordinate multiple machines in a joint farming process. So in silage maize, you have several fields that you want to harvest. You have to have at least one harvester that harvests the maize and all the time needs a transport vehicle driving next to it, because it doesn't have a bunker on its own. But there needs to be a transport vehicle that takes over the yield, and once it's full, it drives to a silo where it unloads it, and where the yield is compacted for storage. And as these harvesters are very expensive, you have to make sure that that you avoid waiting times of the harvest and optimize the overall duration of the plan, so how to minimize that. And therefore, we first started at looking at the requirements that we have, and we will have some kind of temporal planning, because you need to coordinate multiple machines. You have to schedule the machines as resources, and also, of course, optimize the full plan, just to make it, just to reduce waiting times. But then you also might want to execute the monitoring and replanning, because in the case of maize harvesting, you always have deviations from the real plan, and you might want to react to that. And so here's now how this specific architecture of the agricultural domain looks like. So you have the main, most interesting part for us here is the domain encoder and the problem encoder, because that's the most challenging part here. We have to process information about the fields, like boundaries of the fields and size and expected yield, and generate a domain with actions that relate to the harvesting actions of the machines. And as another specialty of that, we also would like to integrate an already existing library Arolib that's just used for generating tracks of harvester on just one field. So it optimizes the path of the harvester on the field, but does not take the silo or multiple fields or harvesters into account. So and that way the solution management logic is a bit simpler, where we mainly want to visualize the plan and also do some replanning in case of contingencies, but we don't have to, in this case, actively dispatch the actions on a real harvester. So, and to give an example how different another TSP can look like, we have an example of service robots and drones. These are using different robot frameworks. So the service robot on the left is using ROS as a framework, and the drones on the right are using Genome. But the overall goal of this use case is to have the main functionalities being the same, and just having smaller wrappers of those functionalities in the different frameworks. So the overall goal is that we develop just one kind of plan execution or monitoring components, for example, that can be shared among those very different robots. And yeah, for example, here, the goal of this mobile pick robot on the left is to fetch the objects and transport them to the boxes, or to hand over the objects like a screwdriver to a human worker. So as said, this service robot architecture looks quite different from the agricultural architecture, because here's the most interesting part is actually in the solution management logic. So that's why we structured the architecture diagram a bit differently, but the main components are still there in those cases as well. So here we are still using the unified planning library, of course, on the right, and we have to create a domain representation of our actions that we have on the robot. But here in the middle, we especially need to develop a plan dispatcher that goes through the plan and sends the actions to a robot, which is represented on the bottom. So those are the in pink, there are the basic functionalities of the robot, like moving the arm, localization, or object recognition. And those are in part interfaced with this existing robot API. And yeah, another part that you also have to develop is some kind of monitoring and also some orchestrator that coordinates the full process and checks what to do next if some error happens. Yeah, and as a third part, we also have smaller work package that deals with very generic TSP functionalities that if you develop your TSP, you hopefully can maybe reuse even parts of that. So therefore, in all the use cases that we actually have in the project, we collected TSP functionalities that are generic and could be used in multiple TSPs. So although I have to mention that we are still in the process of identifying and developing it, because we started more from the bottom by developing first instances of those use cases, and now try to combine or identify functionalities that could be shared. But one existing functionality is the UP bridge, which assumes that you already have some fluent and action definitions, for example, in terms of Python functions of your application domain, such that you can, for example, have a function that calculates the value of a fluent. And then this UP bridge will help you to create corresponding representations on the UP library side. So it has a function to set where you can just give your function, and it will provide a corresponding representation of that function for fluent or an action on side of UP, which you will then only have to enrich with further constraints, for example, of the preconditions or the effects of such an action. And it also maintains the correspondence between those two representations, such that you can more easily execute a plan later on. And we are currently also working on functionalities for plan execution. So currently there's some functionality for plan dispatching, but currently only for sequential plans, but we aim to extend that soon. So now maybe a bit more from your perspective again, now you have your use case and you would like to start developing your TSP, then I think always the first step is that you identify from the use case the exact requirements that you have on UP side. So how the planning problem should look like, but also additional components that you need for for executing the use case, the solution in your system, then you probably would need to create a component architecture that ideally would be based or quite similar to the generic architecture, such that you could maybe reuse some parts, and also therefore check the availability of TSP components. And yeah, for those that are not there currently, you might need to identify and develop additional components. And here's just a very quick overview about the use cases in track C that are already there, and for which we are hoping to get applicants for the developments of TSPs. So we have some examples for in the case of robotics, but also some optimization of urban traffic control or just-in-time bunkering operations, and two of them will be presented in the next two parts of this presentation. And I think Marina wanted to also send this link here where you can have a detailed look at the use cases in the chat, so that you can look at that at our website. Thank you for your attention. Please write your questions in the chat, and I will hand over to the next speaker.
Thank you so much, Sebastian, for your presentation. As Sebastian mentioned, I just posted on the chat the links to all of our use cases. You can know more about them, and if you are a good match to partner with them or not, and go to our website. You have all the information there about the open call. I will post the link after I give the word to Elisenda. And yeah, that's it. Elisenda is the use case number 5, if I'm not mistaken.
Yes,
yes, exactly. Use case number 5, and she will now explain you what her use case is all about. Please take the floor. Thank you.
Thank you, Marina. Let me share my screen. Okay, I hope you see it.
Yes, yeah. Perfect.
Great. So hello, everyone. I'm Elisenda Ventura from Navozyme. And first of all, I would like to thank the organizers for inviting us to present the use case. As Marina said, this is use case number 5, JIT bunkering, or just-in-time bunkering operations at port. Before going into more detail on what's this use case about, I would like to explain briefly what Navozyme, my company. Navozyme is a maritime scale-up. We develop and provide software solutions in the maritime space to facilitate data interchange. And in this case, with bunkering, we are focusing on the bunkering operations, which is the activity of supplying fuel to a ship. So now let's deep dive. And if we think of maritime transport, we know that maritime transport accounts for 90% of so it's moving 90% of the cargo. And what makes this happen also is fuel. Without fuel, there is no movement of goods. So as you can see here, the importance of bunkering operations, not only in the context of maritime transport, but also in the context of global economy. Just to give you a better image of bunkering today, we have estimated that 1 million bunkering operations are carried out around the world every year, which means that more than 300 million tons of fuel are supplied. And because it is fuel and because of the importance, this operation is valued at $225 billion. This is also not only an important activity, but also very complex, because it involves many different stakeholders, from the port authorities that control the port, to the ship owners that, as the name says, own the ships, the suppliers that need to supply the fuel, the surveyors and laboratories that need to make sure that the quantities and the specifications of that fuel are correct, to the ship agents and vessel masters that are very much involved in the operations. So this is, like in a nutshell, the image of bunkering today. But what happens? Because of the intrinsic volatility of the maritime environment, and also because, as you have seen, it's a very complex ecosystem with lots of actors, today there is a lot of friction when these actors need to exchange data. And that means that these actors doesn't have access to the real-time updated information that they need, and this causes bunkering delays, which not only increase the waiting time of vessels at port, but also the fuel consumption because their engines are turned on while waiting. Also the greenhouse gas emissions in that area, which not only affects the port, but also the cities that are near. It also causes or increases the risk of oil spills because it's a very complex and delicate operation. And of course, it causes an increase of the financial cost for everyone and also affects the reputation of the ports. And why this happens? One of the reasons why this happens is because today there is this rule in the ports around the world, so everywhere, that it's called the first come, first served rule, that what it means, it's self-explanatory, but what it means is that a vessel goes to the port and in theory, when it arrives, it should be served in order of arrival. But what happens in reality is that sometimes when the vessel arrives, the services are not ready because maybe there has been another delay in another operation, or sometimes there was not enough notice, or maybe there is a vessel that comes later, but it has priority because sometimes, for example, in the case of ferries, which transport both passengers and cargo, and they have specific routes in a very tight schedule, that they have priority and they go first. And all of that causes delays. For example, here is to give you a better image, a very specific example of a vessel, the Maersk Congo, that was going to the port of Algeciras to get the fuel. And I don't know if you're familiar, but the port of Algeciras is very close to the Gibraltar Strait, which is an area that has a lot of traffic. And what happened with that vessel is that the vessel approached the port, but when it was arriving, it was informed that the fuel was not ready. So the vessel had to keep moving around, waiting. And as you can see, with all these movements that we have here, this is quite dangerous because, as I've said, there is a lot of vessels going in and out of the strait. And this is just one example. Sometimes vessels, especially with bad weather, need to wait in open waters, which also increases the risk of accidents. Sometimes they just move to the next port, and that means that the port is losing business. So there are many consequences for delays, but in the maritime industry, it's understood that this is a very big problem. And with this use case in AIPlan4EU, what we are trying to do is move away from this first come, first served rule in favor of using a plugin application that help us reduce the waiting time. So we are moving away from this model today that it's I sail, and when I arrive at the port, I need to wait because I don't have the resources or the resources are not ready to supply me, to another model. Well, the vessel says, I'm going to arrive in 24 hours. And the planning engine says, no, better to arrive in 28. So then all the resources, services will be available for you, and you will be supplied at arrival. That's what we are trying to do here with just-in-time bunkering operations. And that's where we need your help. How we have thought of this problem. So we think that with a 12-hour notice given to the captains, we have enough to have a huge impact in the sector. First of all, because it is a realistic window, which will also help us manage expectations. Then also because I've said it will have a very significant impact on the both waiting time, fuel consumption, and greenhouse gas emissions reduction. Then also because with a 12-hour notice, we can already be sure of the time that the vessel will depart the port, and also of other constraints such as the resources, the schedules of the nautical services in the port. So with that notice, we can make sure that it can be more accurate, the data that the system outputs. And which is the impact? So if you look at this data, you will see that here, just to give you an idea, we have just considered a reduction of 2 hours in the waiting time. And we know by first-hand experience that sometimes the waiting time can be up to 10, 12, 20 hours. So with just this little reduction of 2 hours, we see that we are saving lots and lots of metric tons of greenhouse gas emissions. We are saving also money substantially. And of course, saving time for all the actors involved. And of course, this also helps us towards the Sustainable Development Goals put by the United Nations. So which are the metrics that we are looking at to make sure that we are successful in this endeavor? First of all, as I said, we want to reduce this waiting time that the vessels on average are having today, which is 2 hours to 0. And then we also want to make sure that the scarce resource, which is the vessel that is going to supply the fuel oil, the bunker barge, also is reduced. So we don't want this scarce resource not being utilized. So we want to make sure that the schedule that the bunker barge has allows them to really supply as many vessels as it can in one day. And now, because I think that maybe some of you are thinking of, okay, but this problem really needs a lot of data. I'm very happy to say that Navozyme knows that, and we have been developing a bunker, which is a platform that allows us to exchange data amongst these bunker stakeholders. So what we are doing is, first of all, bringing all the actors that are involved in bunkering operations in one platform, so they can change various types of data in real time. For example, see, from vessel specification to know the size, the speed, the course, to the ETA, so the estimated time of arrival of those vessels that can be updated in real time, or for example, operational timestamps. So once the operation has started, we also can know how it's evolving and if there are delays or no, or the different schedules of the service providers. This platform has been thought of with 2 modules in mind. One is the one that we have been developing, which is the permission blockchain enabled platform, which allows us to facilitate this exchange of real-time data from the source, which is very important, because then we can make sure that the data that we have is really of the highest quality. And then also because we are facilitating another part, which is the documentation and certificates, that sometimes is also a reason of the delays. And the other part, which is the one that we want to work on during the AIPlan4EU project, it's the planning part. So the optimization of the vessel's ETA to reduce the waiting time and eliminate all these wasted maneuvers that we have seen. And of course here, besides the impact that we have shown before, here we also see how we are going to facilitate the verification of the data that has been provided, enhance cybersecurity, facilitate also the real-time decision-making of these stakeholders, and also, of course, reduce the administrative burden. We have been working on this project for the last year, and this is a project that not only needs real-time updated data, but also needs historical data to train the models. And here, and with this, I'm going to close, we are also very happy to say that we are receiving the support of the 6 major bunker ports in Spain, and Las Palmas and Bahía de Algeciras, which are the 2 first ports in Spain in bunker supplies, are key partners in this pilot phase. So they are going to provide us with historical data, real data, all the aspects of privacy, NDAs have been signed. So we will make sure that once we start this project, we have all the data required to train the models and be able to do this demonstration. So we will be able to support the innovator in any way we can. And with that, that's all. Thank you very much for listening in. And of course, please get in touch if you have any questions about this use case. As Marina said, everything is on the website. You have also our proposal there with much more details. So you can go and take a look and contact me if you have any questions. Thank you.
Thank you so much, Elisenda, for your clear presentation of your use case. So as Elisenda said, go to the website. You can see there more details. I've posted the links on the chat. So just go ahead and see. So now I give the floor to Grigore that will present us with the use case number 6. Thank you so much, Grigore, for being here today. The floor is yours.
Hello, thank you, Marina. I will just share my my screen. I think you can see it, right?
Yes.
Okay.
But it's not in presenter. Oh,
So,
okay. Now
yes,
it is.
now it's
Thank you.
okay. So we are very glad to have the opportunity to present our use case in this meeting. My name is Grigore Stamatescu. I represent the company Applied Research Solutions, and our use case is focused on energy-aware smart planning for flexible assembly line systems. Is plain, however you want to read. First of all, as a brief introduction, so our company is a research performing SME or startup. We founded it in 2020, so 2 years and a bit ago, with the goal of developing data science solutions for industry and energy applications, also to provide research consulting and training services in this area. And we have a key area of expertise in the area of IT and OT convergence in automation, industrial automation. We work together also with the company Astro Automation, also from Bucharest, which is a well-established actor in this field of industrial automation. As outlined, so this presentation is broadly based on the description that we gave in a previous workshop in AIPlan4EU some 2-3 months ago, and we focus on 2 sides. First of all, describing the physical plant, the model flexible assembly line system that represents, as we will see, a host of different industrial processes, and then describing a bit more in detail our planning application. So the key areas where we hope to work with a software development company to bridge the UPF towards our application. Okay, so this what you see in the background is our model flexible assembly line system. This is a pilot system for training and research and development of smart manufacturing solutions. It is modeled based on our productive expertise, let's say, so in the automation project expertise. And what you see here, it's what you will find in a factory, for example, in electronics manufacturing, automotive, food production, pharma, logistics, and other areas. The system is a end-to-end production of a 3D printed part with all industrial grade equipment, meaning controllers, sensors, drives, communication technologies. There are 5 stages: a pallet station, a base piece station, the middle station, which is the robotic cell, where the most complex operations are implemented, then a top piece station, and the storage station. The line can also be engineered for increased supply of parts, so that we can have larger batches. Currently, in the standard configuration, there are 5 pieces, capacity for 5 pieces, but we can extend this. And as we will see, we can also extend this with a mobile robot supply platform. This is a more detailed view for the manufacturing process for assembling the 3D printed workpiece. You see the pallet station, the base piece station, robot and assembly station, where a custom configuration for each piece can be inserted into the MES system. And this, as we will see, it influences also the control of the robot, and then the energy consumption of the process. Top piece station and storage station. Also, what I would mention is that for each pallet, we have a traceability for each part through RFID tags, which can be further, this data can also be processed in the software solution. The robot cell Currently, you see here the example with the ABB IRB 120C robot. We have implementations also with Mitsubishi, with Fanuc, and with Universal Robots. The robot cell interfaces with the PLCs and static frequency converters to control and synchronize the conveyor belt using standardized communication protocols, in this case Profinet. And we also have vision-enabled functionality. So the cell uses a camera from Cognex or IFM to process the visual information and to implement vision-based control of the robot. Something that you see here, for example, a basic example of part detection, color detection of a certain part, determining the center of mass and dispatching the robot accordingly. More than that, what can be or what are the technologies that enable this this flexible assembly line? You see here some topics. We have the control based on PLCs, and these support all the common IEC 61131-3 programming languages. They are Siemens based, but they can also be replaced with other types. And we have a full range of standard-based industrial communication. So from lower levels like IO-Link for sensor integration, CAN-Open for the drives. Some of the drives support CAN-Open. The main backbone is Profinet. And then we have also some specialized protocols, Profibus for some drives, RFID for tracking the parts, and also, let's say, industrial Internet of Things family protocols like OPC-UA and MQTT. As I said, all the equipment is modern, and for somebody that's developed an application on the line, it's easy to have access to the API, to the documentation, and relay the commands stemming from the planning system towards the field level. Various type of drive systems. Of course, the drive strategy influences also the consumption, the energy consumption. Human-machine interfaces for local visualization, the robot, and also what is important for the specific use case. We have two types of energy metering devices. SM signal modules for the S71200 PLC, so local energy measurement. And at the line or at each stage level, we have energy metering devices like this pack, Centron pack family from Siemens. This helps us for a very granular measurement at the operation level at each stage throughout the production process. We also accompany this with a digital twin model. So what you see on the left-hand side is only a graphical representation, but this has been ported to Festos Cyrus. And as you all are aware, when working with these types of industrial systems, a digital twin model can be put to very good use. For example, to generate synthetic data, to simulate faults that otherwise would be very time-consuming and very expensive to replicate in a real environment. So we have the possibility of recording, for example, some traces of production in the real system and then replaying them, introducing some uncertainties on the digital twin model. Yes, so for testing and synthetic data generation. As an option, we also have some experimentation. So we have a lab here in Bucharest, and we are also playing around with this type of mobile robotic platforms in order to support the line production. For example, emptying the storage compartment when it's full, or supplying raw material to the line on demand. So there is a robotic platform. A version of it also has a robotic manipulator fixed on top, and we can control it through reinforcement learning to function quite accurately around the line. Okay, so this is the context. This is the application we propose. So basically, we have this model plant, which is, let's say, one-to-one transferable to various industrial processes. That's the main idea. So it's as realistic as can be. And on top of that, when we first discovered the AIPlan4EU, alongside with our interests, which we were looking at trying to optimize this energy consumption in an intelligent manner, we came up with this use case. So what would be the main objectives? First of all, to implement and test the planning and optimization layer on the line, which would generate energy-aware control decisions. So the control that means for example, the speed of the conveyors, the sequence of the operations of the robot, and other types, which will be discussed more in detail during the project, will take into account the energy consumption as a constraint. We want to validate this. So as you see, we have the means to bidirectionally integrate with the line through standardized interfaces, and to validate the model on the actual line, and support the project objectives in the smart manufacturing. What can we adjust? So assuming that the planner gives us a feasible solution in real time, let's say, corresponding to the actual operation of the line, the planning variables can be, for example, the speed and settings of the frequency converters, the PLC program parameters, the robot arm speed and pick and place strategy, and also the spare parts supply and placement. And this optimal sequence of products and time slots will be generated, which can be correlated to for example, with the dynamic factors which are external, coming, for example, from the energy system, the cost that's at a certain point of the energy, or the availability of the renewable energy. If we want also to have some green credentials in our manufacturing solution. So far, sorry, this is not a very detailed graph, but it's the one we have from some previous experiments. We have collected data. For example, we have data for almost 100 runs, full runs of the line, 95, I think, where we are able to pinpoint exactly and identify each of the operations and try to fingerprint operations through their energy consumptions. Yes, this will be detailed more in depth as the project progresses. We also have digital sensor timestamps. These are very useful for synchronization purposes for each of the pallets. So also trying, for example, to increase the throughput of the line in periods where energy is abundant or readily available. And from the planning perspective, there are two types of data: the constant data and contingent data. We expect that the constant data corresponds to the baseline mechanical and electrical characteristics of the line, of all the components. But we also have contingent data, which stems from various, from wear and tear, from maintenance requirements, for mechanical tuning. So we expect to have some variations over the experimentation period, which will be reflected in the logs, and we'll generate like uncertainty interval, which would give us some space for operational adjustment, let's say. From the planning and scheduling perspective, it will be a hierarchical approach. So as we see it from the field level, let's say, our future partner might have a different perspective, but we start with this perspective where the optimal sequence of parts picking at the robot cell can be optimized considering the energy. Then we move on to the batch, to the optimal sequence of products in a certain configuration that is determined by the planner. And then we can go upwards to plan, for example, the mobile robot platform actions to improve the overall line performance. For example, dispatch an additional storage station for increasing production with lower energy costs. For the integration, what you see here is a general diagram, a component level diagram, which also follows the automation hierarchy of the line. So we have the field level with the field devices, field controllers, local supervisory control. And currently we have broken this in two. So introducing the planning layer would happen here in the middle, where previously we had an open source device like a Raspberry Pi pushing data to Azure and a dedicated edge gateway from Siemens pushing data to MindSphere, to their proprietary cloud. If we break this, we would see the software solution, not necessarily in the cloud, it can be also run locally, connected to the edge nodes, which serve as some data concentrator, running the mathematical optimization procedures, and then relaying the control actions, preferably in the space of the sampling time of the process. We believe this is feasible. At the end, we estimate that we can achieve 10 to 15% overall reduction in the product level energy consumption, and also at the overall line energy consumption. And there will be also some secondary benefits because monitoring, doing this very fine-grained monitoring of the line, we can prove some cost savings from unplanned downtime avoidance. So there are many examples in industry where energy consumption can show us indirectly or can warn us about some impeding faults. Of course, we are interested also in the computational efficiency of the solution. So there is a discussion of the various algorithms that are available in the AIPlan4EU and see which ones are work best for our use case. Finally, and this is my last slide, what we would like to discuss with a potential partner, and this is also documented on the website, is to see how we can implement these three stages using the resources that AIPlan4EU provides, and also validate them in a real scenario. So we have this physical system. We can also assure remote connectivity, so our industrial automation engineers can support the implementation on site and open up the communication so that you have access from anywhere in the world in a secure manner to the line. And we can also, of course, work directly on the line to build out a nice demo. Thank you very much for your attention, and we are available for other technical details until the deadline, either directly or through the AIPlan4EU colleagues. Thank you very much.
And thank you so much, Grigore, for your presentation about the use case 6. I've been seeing that in the chat is being a marathon for Andrea that is answering a lot of questions. So if you have questions, just keep posting them there. He will keep on answering them. And so now I will give the floor to my colleague Luisa that will walk you through all the procedures on how to apply to the open call.
Okay, so thank you, Marina. Thank you for having me. I will share my screen here. So can you see my screen?
Yes.
Okay, sorry. So good afternoon, everyone. So as Marina introduced me, I'm Luisa from F6S. I work with Marina, and F6S is a leading platform that connects companies, different companies, SMEs, startups, and different organizations with investors. But here we are part of a department that work on governmental projects, specifically European projects. And in AIPlan4EU, F6S is responsible for managing the open call. So I will give you a brief of the open call that is quite related with what my colleagues has mentioned before. So here you can see this this picture that is Sebastian has already presented, and Andrea. This open call to Innovators. So this is the second open call that we are issuing, the second and the last one. And in this call, we intend to attract different experts to develop specific tracks. The track A webinar was last week. So today I'm going to focus on the track B and track C, but the process to apply is the same. So in track B, we are looking for a small consortium of 2 entities to address the use case and the TSB developers. It means that we are going to a consortium, 2 companies will apply to and will propose a use case here and also a technology-specific bridge. For track C, we have already selected some use cases. Elisenda and Grigore has already presented. They are one of the use cases selected in open call 2 and 3. So we are now we are looking for technology-specific bridges to address their use cases. So this open call in terms of budget and number of projects in track B, we are going to select 1 project. It means that we are going to fund 2 organizations with 90k euros. And the track C, we are going to select 8 technology-specific bridge developers to address 8 use cases that have already been selected before. And the duration of the program is around 7 months. So who are we are looking for? So we are looking for organizations to address track B, different types of organizations, SMEs, startups, research institutes, universities, labs. Different organizations are eligible here to compose a consortium of 2 entities. We are not responsible for matching companies, so the applicants should apply and agree with another company, for example, to apply as a consortium. The track C, we are looking for individuals, researchers, students, experts in AIPlan, or organizations that can apply as a TSB developers. Organizations should have valid VAT. It means that the organization must be incorporated, and individuals does not need to be an European citizen, but they need to be legally based in an European country, in one of the eligible countries. So regarding the eligible countries, all the countries from EU and associated countries. In the guide for applicants, you will find the links to consult the list of countries, and you can apply by the 31st of January. So now I'm going to move to a more, let's say, practical part of my presentation, because I'm going to show you how to apply through the website and how you are going to be guided to F6S platform to fill the form. So here you can see our framework. So we in the open call team, we work with this under this framework. So we start with the submission of your application. So I signed here that we are here at this point now. We are receiving submissions, so in the F6S platform. So after the 31st of January, your applications will go through an eligibility check. The eligibility check is a very simple process, because we check, for example, if your proposal is in English, if the proposal is from an European country, or if there are any conflict of interest related to the consortium partners, for example, and the SME. So after this process, we move to the evaluation process. That is this one. So our consortium partners that are also experts will analyze your proposal in order to see if it will be a good project for what has been developed internally in AIPlan4EU. So this process lasts around 1 month. And after that, we will know who is going to advance to sign the sub-grant agreement and who will not. So after that, we will go to the implementation phase, and I'm going to explain this, this part in the next slides. But first, I would like to start with a stage that goes before the submission of the form. So in open calls, it's very important to read the rules, because we follow here the FSTP rules established by the European Commission. There are different rules that are not so complex, but it's very important that you read and try to understand if your project, if your company, if your organization, or in the case of an individual, fits in that rules. So how to start the application? First, go to the website, and on the website you find this tab, Apply Now, and the open call session will open. Here you will find a very summarized information about the call. Who are we looking for example, the funding scheme, and different information in a very summarized way. Of course, it's important that you find the information about the track that you would like to apply. For example, track B and track C. So here you will open all the information. You see the information necessary for this track. And then here you will find the documents. That is a very, very crucial point, that you read the documents in order to find the rules, to find, for example, the timeline, the funding schema. So we start here with the open call text. The open call text is a more, let's say, not so detailed information. You'll find some information about the project and an overview of the call. The guide for applicants, that for me it's the most important document here, because there you will find the open call rules and the eligibility criteria, the evaluation criteria, the eligibility criteria, of course, the eligibility rules, different information about the conflict of interest, and how we work, and our framework is also there. So it's important that you read carefully this document. And then here you will find the track template. Here's track B, but you also find a track C template. And this document is crucial because you will describe your proposal. We created a very simple document with not so many pages, but there you need to write and detail your solution. So here you will find just the table of contents that is not so difficult to fill it. And this document is very, very important because evaluators will read carefully and analyze this document in order to make a decision. So one more aspect here for those who would like to apply to track C. Here in this same page, you will find the details of the use cases. So there you find the use case description and the PPT that summarizes or detail the use case. And these slides were presented during the workshop, and I think it's going to help a lot those who would like to apply to this track. So after reading the guidelines, after writing your description according to the template, so it's time to fill a form and submit your application. So on the bottom of the page, you find a button to apply, and you will be guided to F6S platform. So if you are not registered there, please create a login. It's a very intuitive process. And you will fill a form, a very, very simple form, For example, to choose the track that you would like to apply and to write the proposal title, write a proposal, describe the proposal summary. It's very simple and very intuitive. And here you will find the space to upload the document that describes your proposal. Here you will find also the link, but you can also find the link on the website page. And here is just to highlight, because it's very intuitive. Of course, if you are filling out the form, while you are filling out the form, you find this question is just to choose for the track C applicants to choose what use case you are for what use case you are applying. Since you'll be the TSB developer, it's very, very important to choose the use case that you are going to address with your TSB. So after this process, and of course you are going to submit, after the 31st, we are going to start the evaluation of the proposal. So this process encompasses 3 different stages. First, the consortium partners will select the best proposals based on these criteria. That these criteria are also they are also described in the guide for applicants, so you can go there and check the details. And also, of course, we detail the scores, the respective scores for each criteria. So they will analyze the challenge fit, the technology innovation, the impact, the team, only for track B, because on track B we are going to select a consortium, and the work plan. The online interviews are optional, so only if the evaluator raise a very some aspects that would be difficult for us to check out, you are going to be invited to an interview. But since this is an optional step, sometimes it will not be necessary. And the consensus meeting boarding, so all the evaluators will come together to make a decision according to the list of proposals that could possibly advance to the next stage. So after this, if your proposal is selected, you're going to sign a sub-grant agreement. That this is the legal stage of this process, that our partners will contact you in order for you to sign a contract and provide some documents like bank account information and the registration of your company in the case of organization, and in the case of an individual, for example, the ID number. This is they will request different documents during this phase. So after the sub-grant agreement, I will just summarize, not give so many details here, what will happen after you sign the contract. So that is the deployment phase. So you will be engaged for 7 months with the AIPlan4EU project, and this is we call sprint and demo phase. That the sprints are 2 months period of the project that you are going to develop your solution. So each sprint lasts 2 months. And we dedicate 1 month, that 1 month period for tests at the end of the program. So this is a good way to monitor and follow up, and also support you during this period. So you're not going to be alone. Of course, you're going to interact, and you're going to co-develop and with the consortium partners. So you will come on board to become also partners of this project for 7 months. So here you can find the timeline. So the call will close next week on the 31st of January. So the announcement of the selected proposal will come out by the end of February, because during the month of February, we are going to evaluate the proposals. During the month of March, the contracts will be signed, and the implementation phase will start in April until October of 2023. So just to wrap up all the information, it's necessary that you first start with accessing the website. On the website, of course, you will find different information about the project, and of course the open call session. Read the guide for applicants and the track C use cases, because there you will check all the needed information to prepare a good and quality application. Prepare your proposal according to the template available. This is a very, very important step, that you prepare and describe very clearly your proposal so that evaluators can understand and analyze the proposal. Click on the button available on the web page to fill the form. So you will fill the form that is a very simple form, and then you will upload your proposal project. Submit by the 31st, so next week. And here is just to remind you that organizations are eligible for track B, and for track C we will select not only organizations but also individuals can apply. Regarding the eligible countries, European countries from European Union and associated countries can apply. And regarding the numbers, in track B, we are going to select one project. It means that 2 companies will come on board as a consortium. They will be funded with 90,000 euros. And in track C, 8 TSB developers will come on board to address 8 use cases that have already been selected in previous calls for use cases, and the funding is 60,000 euros. So don't miss out this opportunity. In case you have any question, you can contact us by this email address, and you can go on the website, because on the website there are a lot of good relevant information for you. And I will be glad to answer any questions now, and of course later on. If you have questions, as I mentioned, reach out to us by email. So thank you for your attention.
Thank you so much, Luisa, for this walkthrough on the applicational procedures, let's say it like that. Okay, so I think we came to the end of our webinar. Just a quick reminder that the open call closes next week on Tuesday, I guess, by the 31st of January. So be sure to apply before that and go to the F6S platform or to our website. There you have the link to the F6S platform where you will submit your application. And yeah, I think we answered all the questions. Or is there any more? I don't see any more. Yeah, it was a real marathon today with so many questions. Thank you all for being here. Thank you to our speakers. All of you were amazing, and all of you provided so much value to this webinar. And I'm sure that most of the questions of our viewers were addressed by you and also in the chat. So thank you very much. And yeah, reach out, as Luisa said, if you have any doubts further down the line. Thank you so much.
Thank you. Bye-bye.
Thank you. Bye.
Bye-bye.